Hello everyone, and welcome to 8.1 part 2, which is about perimeter and area of similar figures. Remember, similar, this is the symbol for similar. We say that two shapes are similar if they're the same shape but different sizes, which means that the angles are congruent, but the sides are going to be proportional to each other. And so today we're looking at the perimeter similarity and area similarity. So what is perimeter similarity? It says if the similarity ratio of two figures is A over B or A to B, then the ratio of their perimeters is also A to B. So if you think that through, that makes sense. Like if this side length is 3 feet, the perimeter when you go around this shape is going to be a certain number of feet as well. So those are in the same units. So that's a really easy way to remember that those ratios are going to be the same. Whereas area is a little bit different. It says if the similarity ratio of two figures is A over B, then the ratio of their areas is A squared to B squared, which makes sense because area is always going to be in units squared. Like if I found the area of this shape, it'd be 3 times 2 would be 6 feet squared. Okay? So let's look at this, and I'll teach you the shortcuts. This is just a way to make this a little bit faster and allow you to solve some problems you wouldn't necessarily be able to solve if you were not given enough information. It says identify the similarity ratio, the perimeter ratio, and the area ratio of the similar figures below. So the first thing we want to do is find what is our similarity ratio. It also sometimes might ask you to find the scale factor where you'd have to know which one is the new one and which one is the old one. So if I were going from left to right, this shape would get bigger. If I were going from right to left, this shape would get smaller. And so that's when that matters. But because it just says the ratio, it doesn't matter if you write it as A over B or B over A. So I'm always going to do the one on the right first, just because that's what we're used to doing for scale factor. Depending on which shape is new. So I get to compare pieces that are corresponding. So I can compare the 4 to the 2. So 4 over 2, which reduces to 2 over 1. Or I could also compare the 6 to the 3 if I chose that piece instead. 6 over 3. 6 over 3 is still going to give me 2 over 1. So regardless of which one I want to choose, they're both going to simplify to the same thing because these shapes are similar to each other. And because they're similar, I know that all 4 of those side lengths will reduce to the same fraction. So if my similarity ratio, A over B, is 2 over 1, that means that my perimeter ratio, A over B, is also going to be 2 to 1. Let's see why that makes sense. We've seen already this similarity ratio and where it comes from. But now let's actually go through and find the perimeter. Remember that perimeter means to add all the pieces together. So that's also going to be 3, that's also going to be 2. So my perimeter would be 10 feet total, whereas the perimeter of this shape, add all the side lengths together in this rectangle, would be 6 plus 4 plus 6 plus 4 is 20 feet. And so 10 feet over 20 feet, so 10 feet for perimeter over 20 feet, reduces to 1 over 2 as well. Okay? And if we did it the other way around, kind of like what we just did to make it match, again, these are just A over B, so it doesn't matter which one you do. Since it's just the ratio, it doesn't give you a scale factor. So 20 over 10 would reduce to 2 over 1. So that does match. So it's just a quicker way. It's a quicker way. Let's look at what happens for area, though, because area is a little bit different. The area ratio should be A squared over B squared. So you're taking the similarity ratio and you are squaring it. Okay? So these two are always the same, but then this one's going to be different. So this one's going to be different. These two always match. And then the area ratio is going to be different. So we want to square those pieces. So I want to take 2 over 1, and I want to square the A. So 2 squared over 1 squared, which simplifies to 4 over 1. 4 over 1. Okay. Let's check that with the actual areas. When I find the area of this shape, that's going to be 2 times 3, which is 6 feet squared. The area of this one is 4 times 6, which is 24 feet squared. So when I write that as a ratio, that would be, area would be 24 feet squared over 6 feet squared, which reduces to 4 over 1. So you can see how we got that same thing. This was just a shortcut to make it a little bit faster. This was just a little bit faster. So perimeter ratios matched. Those are always going to be the same. And then the area ratio was A squared over B squared. Okay. The directions say identify the similarity, perimeter, and area ratio of the similar trapezoids. So how we were able to actually use the math and still find these fractions on this problem, this was just a shortcut. However, on this problem, I'm not actually able to find the perimeter ratio by hand because I don't know these pieces. Like, you have to know all the side lengths in order to find the perimeter. I only know one side length. So this problem is actually showing me these shortcuts not only make it faster, but they also allow you to solve problems that you wouldn't normally be able to solve because you're missing pieces. Okay, so which pieces correspond to each other? Let's see. The 9 corresponds to the 6. And so I can use those pieces to write a similarity ratio. So my similarity ratio is going to be A over B. So I'm going to stick to the same colors, A over B. And so I'm going to do 9 meters over 6 meters. What does that reduce to? 9 over 6 is 3/2. So my similarity ratio is 3/2. My perimeter ratio is going to be the same thing, 3/2, because it's still A over B. So those are going to be the same. But my area ratio is going to be different. It's going to be A squared over B squared. So that should be 3 squared over 2 squared, which is 9 over 4. 9 over 4. So perimeter ratio was 3 over 2. Area ratio was 9 over 4. Okay. Now this one gives you similar pentagons, but it also, instead of just asking you for your similarity ratio, your perimeter ratio, and your area ratio, they actually ask you to go through and calculate the area of the bigger pentagon because they give you the area of the smaller pentagon. What we don't know is the area of the bigger pentagon, so I'm going to put an X there. We don't know it, so I'm going to put an X. It's going to be X centimeters squared. We don't know what that is. But the first thing I can do is I can find the similarity ratio because these two pieces are corresponding. So when I go A over B, I'm going to do 10 centimeters, A over B, 10 centimeters over 4 centimeters, which reduces to 5/2. So what is my similarity ratio? 5/2. If it asked me for my perimeter ratio, that would also be 5/2, but it doesn't. It skips straight ahead. This problem has nothing to do with perimeter. It has to do with area. So we need our area ratio. How do you find your area ratio? It's 5 squared over 2 squared, which is 25 over 4. Well, why is it helpful to have my area ratio? I know the area of the smaller shape is 27.5. I don't know the area of the larger shape, but I can find it using my area ratio. So if I know that the way that 25 compares to 4, so 25 over 4, that ratio is going to be the same thing as the area ratio of the area of the larger shape to the area of the smaller shape. So 25 over 4 would be equal to the area of the larger shape, which I don't know, it's just X, over 27.5. 27.5. And what this allows you to do is just to cross multiply and solve. So I'm going to type into my calculator 25 times 27.5. And I get 687.5, and then I divide that by 4, which means that the area of the larger shape is going to be 171.875 centimeters squared. So 171.5 or 0.875 centimeters squared because it's going to be in the same units as this area. So we just found an unknown area using our area ratio. So not only does it allow you to solve for ratios, it also actually allows you to find missing areas and missing perimeters. Okay, let's do that again. I notice I have 2 triangles here. The smaller one lists the perimeter of the smaller one. It also lists the area of the smaller one, but we don't know the perimeter of the larger one. And we don't know the area of the larger one. So that's what we're going to be trying to find. So I don't have the area and I don't have the perimeter. That's what we're going to be trying to find in a second. But first, let's start just like normal and let's go find my similarity ratio, which is A over B. My perimeter ratio is also going to be A over B, whereas my area ratio is going to be A squared over B squared. Okay, so what are my corresponding pieces? Well, 20 feet is the bottom of this triangle. These are similar, and 16 feet is going to be the corresponding side. So as far as writing my similarity ratio, that's going to be 20 over 16. 20, or you could do 16 to 20, either way. But 20 over 16, we're going to reduce that. That is going to be 5/4. 20 over 16. 20 over 16. Okay? So if you are confused on how to reduce that in your calculator, please let me know in class. I would be happy to help you. So that is going to be 5/4 here and 5/4 here for my perimeter ratio. That's going to come into play in a second. What does that mean about my area ratio? Well, that's going to be 5 squared over 4 squared. 5 squared is 25. 4 squared is 16. So my perimeter ratio is 5/4. My area ratio is 25 over 16. So now I can actually use that to solve problems. If I want to solve for the perimeter of the larger shape, when I use my perimeter to solve for the perimeter of the larger shape, I'm going to do, I'm going to work with these perimeters. So I'm going to call P is going to be the perimeter. So which ratio do I need to work with? I want to work with my perimeter ratio, which is 5/4. So I'm going to do 5 over 4. So that's big over small is going to be equal to the perimeter of the larger shape over the perimeter of the smaller shape, which is 36. And so, of course, we're just going to cross multiply and solve. So you're going to do 36 times 5 is 180 divided by 4. What is my perimeter of the larger shape? Perimeter equals 45 feet, which makes sense because that is larger. Perimeter equals 45 feet. That is larger than the 36. Okay? Exact same thing when we're solving for area. I have my area ratio. What is my area ratio? It is 25 over 16. So that's big over small. So that is going to be equal to the area ratio of A over 48. My actual area of the big over my actual area of the small should be equal to 25 over 16. So again, just cross multiply and solve. 25 times 48 is 1,200 divided by 16. My area is 75 feet squared. So I can fill that in. Area is 75 feet squared, which makes sense because that is more than that 48 for the smaller shape. So we can use these ratios, these three ratios, 1, 2, 3, in order to solve for missing perimeters and areas as well. Okay. This next problem is a little bit different because instead of giving you corresponding pieces like this problem did, it actually goes ahead and gives you the actual areas. It says the actual area of this shape is 50 centimeters squared. The actual area of this shape is 98 centimeters squared. So if I wanted to come up with my area ratio, I could say the actual is 98 over 50. 98 over 50 reduces to 49 over 25. So what is my area ratio? My A squared over my B squared? That is going to be 49 over 25. So what this wants you to do is to go backwards. That's the one that's A squared over B squared. Both of these should be A over B. So how do I go from something that's squared to something that's not? I'm going to take the square root of both sides. So 49 over the square root of 25, which is going to be 7/5. So if that's 7/5, then the perimeter ratio is also going to be 7/5. So that's just the square root of the A squared over the square root of B squared. Okay? So we took the square root of both sides. All right, same exact thing on this problem. We have two triangles with areas that are 12 and 75. So that's going to be 12 centimeters squared over 75 centimeters squared. 12 over 75 reduces to 4 over 25. You could write 25 over 4 or 25 over 4 or 4 over 25, either way. So what is my area ratio? My area ratio simplified to 4 over 25, which means that the similarity ratio, because this is A squared over B squared, is just going to straight up be A over B. So I'm going to take the square root of the top and of the bottom, and so that's going to be 2/5. If that's 2/5, then this is also going to be 2/5. All right, so your homework is on the back. You've got some problems to try, and we will check that in class tomorrow. I hope that you have a wonderful day.